First, you must realize that you have no idea before you can know the idea. We scan across all the frequencies if we want to learn anything new. Let us begin.
What has physics done for me lately?
Furthermore, the equation E is equal mc squared.
We have now acquired a fateful power to alter and to destroy nature.
That's like when you're in physics and you go to Dreamworld saying, oh, this is a physics excursion.
Science. What is it all about?
The whole of human history all falls in the dust of one stroke of the nail file. You can't really get to grips with evolution unless you realize what an enormous amount of time.
Our own planet is only a tiny part of the vast cosmic tapestry, a starry fabric of worlds yet untold.
You're tuned in to what can only be described as the best radio station on this blue dot we call Earth. It is, of course, 4ZZZ, be it on your wireless radio using the classic frequency of 102.1 FM, digital devices such as DAB or smart speaker, listening via the Community Radio Plus app, or streaming us live from our sensational website at 4zzz.org.au. And of course, you can always listen back to our show or any 4ZZZ show using the ingenious on-demand feature also found at that URL. We also now have a weekly podcast of the show for your listening pleasure, curated by Toby, a condensed version of the show without the music, which my mum prefers. Just search for our show name, which is, of course, No Idea, spelt with a K, your weekly dose of science. And joining me for this episode to speak about all things science are three of my favourite science influencers. Howdy, Peter.
G'day, Max.
Gabrielle.
Hello.
Ellie.
Hello, all. This has gotten so awkward.
It's so slow. It's like when you try and put your lecture on 1.5 or 2 times speed and you actually accidentally hit the half speed. It's the 685th episode, Max, which it is indeed of this show of ours. Do you know there's a galaxy called NGC 685?
On the tip of my tongue.
There is. It's 58 million light years away from Earth.
Is it habitable?
It's does it have what?
Is it? Can you live on it?
Well, it's a galaxy, Max. I'm sure one of the planets, one of the 100 million stars that's estimated to be in this galaxy will have a planet that you could live on for at least a few seconds, Max.
Oh, cool. Okay.
But it is renowned for across that 60,000 light year width with 100 million or so stars in it. It's renowned for being very round as a galaxy.
Oh, that's nice. A rotund
NGC 685. Coming up on the show, Max, I've got an experiment I'm going to run on you. On your creativity. And I've got to get into, by popular demand, a study that came out recently showing that size truly does matter in humans, but not for the reasons you may think. Max, what have you got?
I'm going to talk about how we could have built a better Titanic, I guess.
I think that's there, yeah.
Which wouldn't be hard, I guess, when you think about a boat that just actually stays afloat. It'd be really good.
Be a good one. Mm-hmm. Yeah, one with lights maybe.
Peter?
Good idea.
Red flares maybe.
I'm going to be talking about some depths of a canyon and what did not appear there, and then also, hopefully, a new way to save sharks.
Cool.
Ellie, you got anything?
Yeah, well, I'm going to bring you a story on some black holes and dark matter today.
Brilliant. There you go. Hey.
What's the matter with you, hey?
Hit us up, Peter.
There is something missing in the North Pacific. Does anyone want to guess?
Something missing in the North Pacific.
Cold, icy waters of the North Pacific.
Is that where that ocean gyre is disappearing? The big conveyor belt of water?
One of them, yeah, kind of. It's slowing down at the moment, not disappearing, but that is not what I'm talking about. It's much smaller than that.
Much smaller. Plankton.
Nope. Well,
Dark
it does have a
matter.
planktonic stage. I don't know enough about dark matter to know whether it is or is not disappearing there. And I also wonder whether dark matter could disappear. I don't know. Maybe that's a question for later. Let's have a listen.
I don't see no worms. You see worms?
No ones at dogs here.
I see a worm, but I don't think
a worm?
yeah, there's a little worm right there, but it's a polychaete.
Yeah. Not the kind of worm you want.
Yeah, it's not the zombie worm.
Not a zombie worm?
No.
Yeah.
Zombie
That's
worms.
what's missing. Zombie worms. No further questions. You will hear about them later. I'm going back to the beginning. That's all you're hearing about zombie worms for now. So the clip you just heard was from a group of scientists from the University of Victoria in British Columbia, Canada. QS ranking, please.
Ooh. University of British Columbia.
Oh.
Yeah, I'm thinking around that. 250.
358. Congratulations, Max. And so these researchers are retrieving a whale bone that they left on the ocean floor 10 years ago. So a bit of time to leave something somewhere. You know, it's good that they remembered where they left it. I might not have. Specifically, they left it in...
It was near that really big wave.
It's like, also, the seafloor is just sort of flat and looks just a bit like murky there. So there's not like a landmark you can put it near. You'd be like, oh, crap. Left a bit, right a bit. Maybe more right. So this specifically was in Barkley Canyon off of Canada's west coast, about 1,000 meters below the surface. And the reason they did this is to simulate natural whale fall. This is an area where humpbacks and a couple of other whales do migrate through, so it is possible that a whale could die and fall there and create whale fall. Whale fall is the process of whales, falling to the seafloor after their deaths. The deep ocean is fueled by these rare but very powerful pulses of food. So whale fall being huge because it's a massive whale that sinks to the seafloor. It delivers a huge concentration of carbon and nutrients to the otherwise food-poor environment.
Can I ask a question?
Yeah.
Yes.
Does this story involve any deep-sea cows?
Yes.
I was just going to say,
that.
it does not. I do think dropping whale bones seems like a better idea than just deploying a cow like we had last year, the cow deployment. I mean, it was interesting, but I don't know how well it simulates whale fall, given that it's, and I can't stress this enough, not a whale. This was a whale. It didn't have as much flesh on it as the cow did, so slightly different. It was just the bone. They also dropped some wood down, some pine, which is a different thing called woodfall, which is when trees fall into the ocean and then they sink down. That is also a process that happens. And they also dumped a rock, which, yes, was the control, because rocks don't do much, though I love them. Anyway, they got these materials and they dumped them in this canyon and then they just left them there for 10 years. But don't worry, they weren't alone. They also had a high-definition camera keeping them company for 10 years. Which is kind of phenomenal. If this is like, I think, the peak of slow watching TV. Like, forget about watching someone on a train for 12 hours. 10 years of looking at the same spot in the deep ocean. That's it. That's what I want. I want to fall asleep to that.
What was the setup on the camera? What, take a photo every day or something?
Not a photo, a video.
A video?
It was a video.
Where's all the data stored?
They didn't mention that specifically, but they did go back periodically, like once a year, to go and do specific measurements and checks. They had a remote-operated vehicle, so an ROV, that they'd go down and they would like take measurements and take photos and specific videos at the time with an even higher definition camera. But there was a camera with them pretty much all times. So they were expecting to see a couple of things, but one of them was, in fact, zombie worms, otherwise known as Osedax, Bone Destroyer. That is literally the translation of their name, is Bone Destroyer. Oh, sorry, Bone Devourer. My apologies. Better, Bone Devourer. They have no mouth. They have no digestive tract. They have no anus. And yet, they are one of the few creatures that can make whale bones completely disappear. How do they do it? They survive by drilling themselves, specifically this like root-like structure of themselves, into the bone. And then these roots actually host microbes which pull the nutrients out from the bones and nourish the worms. So it's a symbiotic relationship between the microbes and the worms. And then the bones are thus recycled back into the ecosystem. Fantastic. The worms, by the way, are very, very small. Individually, they look like mini shriveled trees with a big root ball and then one trunk and like 3 very terrible looking limbs. Like if you can think of like when you plant basil and then in a few months later it dies, kind of like that, except without leaves.
Sure.
That's sort of the idea of what this looks like. What, you haven't lost a basil or two in your time, a supermarket basil. They are very small though, so when they colonize a whale fall, if you were to find it, it kind of just looks like the bones have grown a very lively red fur. They're like dancing around, so they're pretty tiny. But they're also relatively easy to spot, given that they make that fur-like appearance, and it's easy to see when they've been on the bone because they leave those telltale drill holes and marks in the bone. They change the way the bone looks after a while. But over 10 years of looking at these bones, nothing. The zombie worms never came. And the researchers think they know why. They actually left the bones in that specific canyon for that reason, because it's hypoxic. So the depths of Barkley Canyon are actually a naturally low oxygen kind of space, sitting within an oxygen minimum zone, which means it's very, very, very low concentrations of oxygen. And the researchers think this is likely why the worms didn't show. Much like many other creatures, including myself, they like oxygen. Oxygen's kind of useful and nice. But the concerning thing is that with climate change and other human-driven activities, these oxygen minimum zones that are somewhat normal in those areas are expanding. They're becoming a lot larger. So it is likely that these worms will fail to colonize other whalefall, real whalefall, not just a bone left by scientists. And worse, they may lose their entire species. So adult ossidax typically live on the whale bones, but their larvae travel long distances through ocean currents to colonize new whale falls, sometimes hundreds of kilometers away. So if those habitats disappear, so essentially, or stop functioning properly, so even though there's a whale fall, they can't colonize it because there's not enough oxygen, connectivity between those whale fall sites, which aren't that common, breaks down. And over time, that could really easily, quickly lead to declining diversity of ossidax species across entire regions of the oceans. And we wouldn't want to lose the zombie worms because, unlike their silver screen namesakes, they can't come back.
If you get bitten by a zombie worm, do you also become a zombie worm? I
don't think you'd want to. It doesn't sound like the most exciting life, to be honest. It doesn't sound fun to be a zombie worm. Although neither does a zombie, I guess. But no, they don't bite. They don't have a mouth, Gabe. No mouth, no gut, no anus. How's it going to bite you?
Fair enough.
Go for it, Gabe.
I'm a little nervous about this one because I'm going to try and pull off a live experiment as we're going through this story.
Yet again, Gabe treating us as hamsters.
So, my guinea pigs, I would like to start off. I'm going to do this a little different to the study in that I'm going to let the three of you do it when in the study it would just be one person doing this test.
Okay, so we can collaborate.
So it's going to be a collaborative test to see how we go. What I would like from the three of you is to list 10 words that are as different from each other as possible in all meanings and uses of the words. So you can only use single words. They have to be in English. They can only be nouns, no proper nouns, no specialized vocabulary like technical terms, and you need to think of the words on your own. Don't look at things around you. So I'm going to start with Peter.
Lollipop.
Lollipop. Max.
Cow.
Yeah, Ellie.
Pot plant.
Pot plant. Single word, but that's fine. We can put that in. It's all right. We'll put in pot plant. What you got, Peter?
Gravel.
Yep.
Whale.
I have to write these down as we go. Whale. Yep.
Sink.
Sink. Peter.
Barb.
Barb. Max.
Motorcycle.
Motorcycle. Ellie.
Footpath.
Footpath. One more from Peter.
Pudding.
Pudding.
No,
fantastic. What we're doing here is testing your creativity. I'll get into the scores in a moment. Because this is called the divergent association task. It's widely used as a very quick psychological test that can try and measure your what's called divergent creativity, the ability to create diverse and original, create diverse and original ideas from a single prompt. That was interesting because you had to sort of wait for the other person to say something and then come up with something. So you were still getting tested in an interesting way. So an example of highly creative responses include things like galaxy, fork, freedom, algae, harmonica, quantum, nostalgia, velvet, hurricane, and photosynthesis. That might get you
I think they've gone to the circle there,
though. And it spits out a score on a scale of 0 to 100. And so these performances are then strongly linked. This is going to be the new Mensa
for art students.
The new Mensa for art students. This performance is then strongly linked to results in other more established and more in-depth creativity tests like writing, idea generation, and creative problem solving. So a really cool, quick tool to use to test creativity. What the thing is with these, though, it's like we always say with psych tests, is they're never really testing what they say they're testing you on.
Yeah.
If you would like to participate, feel free to text in 10 words or have Google that score, because there's a test that'll come up. I think it's run out of who runs it? CNN and one of the unis, University of Toronto, I think. And so you can have a go. You just plug in the 10 words, and then it will give you your score. Text in on 0420626733 if you do it and have a score. But what this specific study that's recently come out was testing was how are humans faring on this DAT score compared to AI LLMs?
Oh, God. Everyone worry.
So while right before we came back on air, I asked ChatGPT 5
this is right
the same
in their wheelhouse,
question.
Isn't
The same question. And so I thought we'd compare the results of the No Idea Room and the results of ChatGPT 5. Worth pointing out, they only tested GPT-4 in this study because that's what was available.
Right.
The sluggish pace of publishing means that there's new GPTs already out. But this was in Nature's Scientific Reports journal, led out of the Université de Montréal in Canada. QS
What's
ranking.
the Canadians today? 256.
168.
Oh.
They tested a couple of different models, including ChatGPT, Claude, Gemini, and others. So to start off with, the results you three got, you scored 81.96
Hell yeah.
out of 100,
That's
which they
dope.
say is higher than 72% of people who have completed this task. You got a very high score.
I mean, we do have 3 brains on it, so you'd hope so.
It really liked gravel and it really liked motorcycle.
Oh, nice. Yeah.
When I tested GPT-5, obviously this is only one run of it, on my account, so it's going to vary, but it scored 72.74.
Better than a
So
computer.
you beat the computer, which is very interesting because when they ran these results, the humans on average beat Gemini, they beat Claude, they beat GPT-3, and they beat a bunch of others that you probably haven't heard of, LLM models, large language models, and they lost to GPT-4. So
Can I ask a question about this? Why, if I was ChatGPT, I've got essentially the world's largest brain filled with all of the words in the world.
Yeah.
Why wouldn't I, if someone asked me to pick random things, I understand doing random stuff with computers is difficult, but wouldn't you just get a large selection of those words and pick at random 10 of them? Because you don't have to work like a human brain. You just have to pick from, why can't you just pick randomly like it would be like
prompts
picking
that I
random
gave
numbers?
ChatGPT this morning was very similar, almost identical to the one they used in the study, and which is what I read out to you. The list of 10 words that are as different from each other as possible in all meanings and uses of the words, with those rules attached. What they found is on average, the GPT-4 outperformed humans on this creativity test. No, it wasn't by much. It was sort of the difference between like 81 and 84 in this average score. But most of the time, it was outperforming humans. And by playing with the prompt and the temperature, what's called the temperature of the LLM, which is sort of how crazy you let it be, how tight you want the response, how uniform you want the response. If you increase that temperature, it does increase your creativity in some cases. But what they also found was that creative people, the top chunk of the human bracket, still outperformed every single one of the large language models. So on average, humans were getting outperformed by GPT-4, ChatGPT, but the top chunk of people, particularly the top 10%, was just a huge gap where they were scoring above 90 on this thing. Even close to 100, like 95 in some cases. And the GPT-4 rarely got above 90. So really interesting results where AI can now compete with people's creativity, at least in these basic tests. They did also then go on and do other creative writing and haiku creation tests and found similar results where on average, the ChatGPT-4 was creating more creative responses based on these scoring mechanisms for creativity. But the top chunk of humans was still outpacing by a significant chunk what any of the models could do, including the best performing one, which was GPT-4. The author's take is very positive, I think, about this. Saying that even though AI can now reach human level creativity on certain tests, we need to move beyond this misleading sense of competition rather than signaling the end of creative careers. The findings suggest a future where AI serves as a creative assistant, which is a very
that's a one way to look at it.
favorable way of considering that, which may differ from people who are losing careers.
Yeah, I'd like to know how
creativity of AI.
writers think that they could use AI as a creative tool that does not replace them? Like, what's the midpoint there that they're trying to get towards in that statement? I'm interested in that.
But that's where we're at. GPT-4 can now outperform human on basic creativity or common creativity tests, and I'm sure the others will catch up as we go, but the top chunk of humans is still outpacing them. Interestingly, the top, I'll give you the top 3 words that GPT-4 and humans use. So GPT-4's most popular words, which are in a lot of them, like in over half of its responses, it used microscope and elephant.
Right.
At least, and then in 40% of them, it used volcano. Whereas the human responses were way more varied, and it's sort of like 10% of the case, around about 10% of the time, the words car, dog, and tree appeared.
Okay.
Yeah.
That's interesting, isn't it? Because I was going to say car, and I thought, no, I'll make it a long word. I'll make it motorcycle. So yeah.
Nice.
Okay.
But for me, it was truly, I waited for something to present itself at the front of my brain. That was it.
But you did well. You scored, what was it, 82?
Yeah, bloody
out of 100. Very good score.
For 3 of us.
For 3 of you. That's what I got, Max.
0, 1, 2.
And this is what they recovered using AI in the data set.
Thank God someone's working on this. I don't know what I'd do without it.
You're tuned into 4ZZZ, and the show is No Idea with me, Max. We've got Ellie, we've got Peta, and we've got Gabe, and I've unlocked the door, so go for it. Let's do this, part 3. Researchers at the University of Rochester, QS ranking
460.
120.
236.
Damn.
More specifically, their Institute of Optics has developed a new process that turns ordinary metal tubes into unsinkable ones.
I heard about this.
Yeah.
Unsinkable
And by that, I mean, I
metal
read the title.
tubes.
Yeah.
Can't sink them, Gabe.
No matter
Okay.
how long they are forced into water or how heavily they are damaged, they simply refuse to sink. The study has been published in Advanced Functional Materials entitled Geometry-Enabled Recoverable Floating Super Hydrophobic Metallic Tubes. That just rolls.
Fantastic.
Off.
Incredible.
By etching the interior of aluminium tubes, the researchers created microscopic hollows on the metal's inner surface, making it super hydrophobic. When one of these treated tubes enters water, the super hydrophobic surface traps a stable bubble of air within, preventing the tube from getting waterlogged and sinking. The mechanism is similar to how diving bell spiders trap an air bubble to stay buoyant underwater, or how fire ants form floating rafts with their hydrophobic bodies. Lead scientist Chun Li Go says, importantly, we added a divider to the middle of the tube so that even if you push it vertically into the water, the bubble of air remains trapped inside the tube and retains its floating ability.
Does it spin a lot though then?
It must.
Because if we're moving into, you mentioned something about the Titanic, so I'm assuming we're moving into boat building territory.
We are.
And I've just got to imagine that if this turned into a boat, you'd be spinning a lot.
Well, you'd think, like, as the Titanic went down, it would just come back up again, wouldn't it?
Right, but then everyone inside, like, when you hit a wave, when something's super buoyant, when it hits a wave, it tends to just roll.
Yeah.
Especially if it's a tube. I mean, I understand that it probably wouldn't be tube-shaped. But I just can't help but imagine with all this hydrophobia that they're actually just going to start repelling themselves in the water and start rolling around.
Surely the idea would be that you put it on the inside of the ship in case it breaks.
Yeah, it's a fail-safe.
That makes more sense.
Yeah.
That way no one's rolling around. Champagne on the floor.
The orchestra. Now, Professor Go and his lab first demonstrated super hydrophobic floating devices in 2019, featuring 2 hydrophobic discs that were sealed together to create their buoyancy. But the current tube design simplifies and improves the technology in several key areas. The discs that the researchers previously developed could lose their ability to float when turned at extreme angles, while the tubes are resilient against turbulent conditions like those found at sea. Professor.
I mean, great.
Yeah, we tested them in some really rough environments for weeks at a time and found no degradation to their buoyancy. You can poke big holes in them, and we showed that even if you severely damage the tubes with as many holes as you can punch, they still float. And this is where I'm thinking the maritime industry could use multiple tubes linked together to create rafts that could be the basis for ships, buoys, and floating platforms. In lab experiments, the team tested the design using tubes of varying lengths up to almost half a metre. And Go says the technology could be easily scaled to larger sizes needed for load-bearing floating devices. And finally, Eco Radio, if you are listening, this research could be used to create a renewable energy platform. The researchers demonstrated how maintenance-free rafts made from the etched aluminium tubes could be used to harvest the kinetic energy from oceans to generate
for wave energy
electricity.
work.
Yeah.
Because they wouldn't sink. Yeah,
Correct.
maybe. That'd be interesting.
And
Does water animal lizards use this sort of thing as well with their underwater scuba breathing, right? They jump into the water, they have a bubble on their
That's more
head.
for their breathing, though. It doesn't help their buoyancy.
No, but it's the same idea of the bubble formation based off
Theoretically,
the physical properties of their
Yeah,
head.
the bubble. The bumpy heads keep.
Good stuff.
Cool.
So they put these 26 babies into these MRI machines, and
At the
they were
same
very
time?
proud of being able to get them
that fit.
one at a time.
They're all strapped in a circle around the machine. Sorry.
That's right.
You shouldn't have mentioned babies in an MRI machine.
Yeah.
Just told us that they measured their brains. It's just so funny.
Max, I kid you not.
Yeah.
I kid you not. I have a backup story this week that involves babies in an MRI machine if we have time.
Plural? Is it plural this time?
So I went too early on that one.
We'll see if we get to it.
You tune into the 4ZZZ, and the show is No Idea with me, Max. We've got Ellie, we've got Gabe, and we've got our friendly neighbourhood marine scientist.
Do you know what tuna is?
Fish.
It's fish!
Thank God someone's working on this. I don't know what I'd do without it.
Fish are friends, not food.
Great start. Gabe, what does the cat say?
Yeah.
Max, what does the chicken say?
Cluck, cluck.
And Izzy, what does a shark say? All right. So, we can all probably agree that sharks are amazing. They're some seriously cool fish, but they're also very important to the ocean. They are high-level predators. They're critical to balance in the ecosystem, top-down balance, which is why everyone is freaking out about just how bad their population losses are. We're talking about 1/3 of all shark species being overfished and pushed towards extinction. Sorry, shark and ray species. So shark populations is something that a lot of people are looking at, and shark bycatch is a global conservation issue that we're trying to look at. So bycatch is when something is caught not necessarily intentionally. So when you're fishing for something else, you accidentally also get something that you don't necessarily need. Now, some bycatch can be sold and will be sold, turns into its own economic product. Some isn't. We're going to sort of just take the broader look at whether it was meant to be caught. So we're talking about that sort of bycatch. So millions of sharks are caught as bycatch every year. Some estimates suggest tens of millions of sharks are affected annually, and it can be a huge issue because taking sharks out as those key predators can destabilize marine food webs, reduce ecosystem resilience, and push those vulnerable species towards collapse. So one of the things that we look at when we're looking at bycatch, especially in the global oceans, is long-line fisheries. So long-line fisheries, it's very much what it says on the tin. It is a long line, sometimes kilometers long, with individual hooks that sort of fall down from that singular line. And they are used to target tuna and swordfish. They're one of the major issues because tuna and swordfish, also big predators. So they tend to hang out in the similar areas that sharks do. And so catching, those fisheries catch a lot of sharks. It's a big issue with shark bycatch. It's also not great for the fisheries to catch all these sharks because every hook that you catch a shark on, you don't catch a tuna or a swordfish on. You also lose those hooks, you get damaged gear. It can be a safety risk for crew when there's a shark on the line, all sorts of things like that. And there has been various gear modifications that have been trialed to reduce this bycatch, specifically shark bycatch. But most of those do also reduce the catches of the fish that you're trying to get. So companies don't tend to implement them because they don't want to make that trade-off. So, like many before them, some researchers from Florida Atlantic University, and we had this one last week, so I'm hoping you know it. What's the QS ranking?
Oh, I've completely forgotten.
Yeah,
Has anyone got anything?
185.
Of Florida Atlantic University.
850.
Oh, that's right. Yeah, this is the range, 1,000 to 1,200.
That's exactly right, Max. It's a range. Not good enough for Florida. They wanted to find a middle ground between this, deterring sharks from the baited hooks, because they are all baited, or usually baited, without reducing the catch of those species they're trying to get. So they were particularly interested in exploiting a well-known biological trait of sharks and other elasmobranchs, which is that they have highly sensitive electroreception.
Yes,
so
good,
they can
okay,
detect
yeah.
extremely weak electric fields in seawater using specialized sensory organs called the ampullae of Lorenzini. If you've heard me chat about them before, especially their noses are very, very, very sensitive to this. And so they were kind of thinking, I wonder whether we could use this sensory ability selectively, so repelling the sharks while leaving tuna, swordfish, and other target species unaffected. So this is what they did. They put together zinc and graphite in seawater. And it turns out when you do that, you get a very small electric field just from the galvanic chemical reaction.
Zinc and graphite.
Zinc and graphite, so pretty basic stuff. The electric field is very localized around the hook, so that's not really a problem. That's usually what sharks are used to. They're not used to big electrical fields that you can feel from, a long way away. It's usually very close up that they would feel it anyway. So it's localized around the hook. It is detectable by sharks, and it's not known to affect most bony fish because they can't sense it. So why would they notice it? The device that they've made is patent pending, but it is highly inexpensive, widely available materials, zinc and graphite, practically everywhere. And they used components that are already familiar to fishers. So things that are already sort of around. So it should be easily accessible. Then they tested it to see, like in real conditions, to see whether it actually reduced shark bycatch, which is the big thing that we're looking at, real fishing conditions. They did field trials using standard longline gear. They deployed the longlines fitted with treated hooks or untreated hooks, so the zinc graphite on one of them and regular on the other. And they did trials targeting both demersal sharks. So demersal means things that hunt and live near the sea floor, and they did that in like shallower coastal locations. And they did that near Florida and Massachusetts, if you know where those are. And then they also tested pelagic sharks, which is an open ocean species. So they went into the Gulf of Mexico to do that and went around and did some long lining through there. From that, they recorded the number and species of sharks that they caught, the catch rate of the target species like swordfish and yellowfin tuna, and then were able to compare that to, commercial operations. So the cool thing about this is that they had clear, measurable differences between the treated and untreated hooks. In the demersal trials, so those bottom sort of species, the treatment reduced coastal shark catch by 62 to 70% compared to the untreated hooks. Now, I don't expect anyone to be reading about fisheries bycatch on the regular. It's a whole other thing. But as someone who does, that is a significant change.
Just by coating the hooks in a combination of zinc and graphite in a specific, I'm assuming there's
it'd be a specific alloy, yeah. But
it's chemically interacting in a way slowly that creates an electrical charge that the sharks are detecting as they get close to the hook.
Yeah, exactly that.
Wow.
So usually when we talk, there's loads of different fishing methods, there's loads of different what's called bycatch reduction devices, so different little things that you can add to your methodology to try and reduce bycatch, especially of threatened and protected species. This is just yet another version, but that is a very, very strong result from one of these devices, as far as I'm aware. The strongest deterrent effects were found with Atlantic sharp-nosed sharks and black-tip sharks, which are quite common. And the most important thing to the researchers was that the catches of commercially important fish were not reduced. So they did not reduce the catch, but they dramatically changed the amount of sharks that they were getting. They also found in the pelagic, so the open ocean stuff, that swordfish and yellowfin tuna were caught at similar or slightly higher rates on the treated hooks.
Maybe just because there's less sharks already on the hook?
Yeah, I mean, you'd assume the hook isn't being used. Look at it, it's now available. But they did think that it shows that it's not actively discouraging target species either, which is very, very good. So they've used that. It's great, really cool thing. I just want to put in one little caveat here, and this is from me. A huge but here. is that while this is very, very promising and the researchers are super excited about it and the paper reads very positive, I have read other research looking at exploiting this exact same sense of the electroreception in sharks for many things. I'm pretty sure I've also read about it in bycatch reduction, but specifically things like surfboard-based shark deterrents. And they do have varying results. So sometimes they deter them, sometimes they attract them. After all, sharks use this sense to find prey. So it is sort of interesting that they would use it as a way to deter them from something.
This is how this sort of shark deterrent on beach sort of thing has gone over the last 10, 20 years or so. Is someone goes, wow, we made this thing that uses this sense of a shark, like its electroreception or its sense of smell, and it repels a lot of them. It did attract those specific ones though, because they were like, oh, let's go check that out, or something
they are
like
quite
that, or
intelligent
they
and
get
curious.
used to it, or whatever happens. So
Yeah, so I think while this is really positive, it's promising, I think we really need to see some replication and scaling of this to be able to really check that it is something that works. But if it is, then that would be huge. It would be a major thing to be able to put a really low-cost treatment to your hooks to at least above the board fisheries around the world would be doable. So that it's a really, really cool study. We just need to see some replication before we start, moving on to the next issue.
You're tuning to 4ZZZ, and the show is No Idea with me, Max. We've got Maximillian, we've got Ellie, we've got Gabe, we've got this.
Okay, it's time for the best part of the show. Loosely defined as science, yeah, you already know. Everybody listens to 4ZZZ just to hear us talking about what Butters just did. Subscriptions just keep rolling like the tires on a car. But something tells me that our science curves won't go far. But unlike an engine, I won't keep you in suspension. We're all here to hear him talk, so let's give him attention. You're not ready for when he starts rapping. Gonna hand the mic to Max, and I'm not talking Van Stappen.
The shakedown happened in F1. It was in Barcelona. 5 days of private testing saw 10 of the 11 F1 teams trial their new 2026 machinery. So I'm just going to table it, put it to the floor. Have we learned anything from last week's shakedown, Gabe?
From last week's shakedown, well, Mercedes pushed out a whole lot of laps, didn't they?
They did.
In this shakedown that we weren't allowed to watch the broadcast of, but had daily highlights posted and lots of news coming out from, and photographers everywhere. Well, look, this is the fun bit of F1 where everyone's sort of jostling and hiding and figuring stuff out, and the speculation runs wild, and people go, oh, I wonder, are they fully showing their full hand here, or are they just playing some of their cards and testing bits and keeping themselves a bit withholden until qualifying in the Australian GP in a month's time. But yeah, it was interesting. I think you'd sort of still be backing the top teams though, wouldn't you, as the main contenders for this year, just based on the run time and the times that they were putting in. The Mercedes, the Red Bull, the McLarens and the Ferraris, probably maybe in that order, would be the ones who are looking the most promising at the moment, but who knows?
And that's the exciting bit. So when we
What do
go
you reckon,
to Melbourne...
Maxi?
I fully agree. I think, don't count out Ferrari, I think, because they set the best time overall. But, I mean, that means nothing, right? We don't know fuel loads. We don't know, what their run plans are per se. But as you say, definitely great to see Mercedes getting that lap count up. Also good for Red Bull Ford. I mean, this is their first actual power unit built at the Milton Keynes campus. So to get, 310... how many laps on the board? 621 laps on the board for a brand new power unit. It's really fantastic to see.
And to be fair, they did steal a lot of Mercedes technicians back in the day.
They did, yes.
So it's
from Brackley.
probably just a Mercedes engine.
Well, no, hang on. I don't think they can take the paperwork with them.
Just the knowledge on how to build a really good power unit. Yeah,
exactly.
So they... so Mercedes, amongst the teams that ran, they did 1,135 laps. So that's pretty good reliability. And
that's across all three teams. Well, sorry, 3 of the 4 teams that they're supplying.
Correct. And then Ferrari also had 3 teams, and they travelled almost 1,000 laps. And then there was Red Bull, which did 621 laps between their 2 teams, Red Bull and the Racing Bulls. So, that was pretty cool. So you got to start to worry for Audi. The true German manufacturer, let's say.
Yeah, it didn't start well for them, did it? They broke down pretty quickly.
Yeah, it was like on the first day they did 27 laps and then 68 and then 148. So they might have sorted it all out for the last day to do 148 laps, which is
Yeah.
still well down overall for someone like Mercedes, who did 330 laps, like on the final day or something. Anyway, amongst the teams.
I mean, they're
Yeah.
still faring better than Honda, though, who only managed a total of 66 across the 2
laps.
days that
Yeah,
Aston attended.
That's right. And they only tested for 2 days, or 1.5 days, didn't they? Aston Martin.
Well, they got 5 laps in with Lance
Yeah.
before the thing, gave up.
Okay, so they're saying Mercedes is probably the one to beat this year, but there's that controversy with the engine and the ratio.
Getting a bit of an additional compression ratio beyond the regs. I think Audi are particularly disappointed by this.
By the book. Welcome
Yes.
to F1, where no rules are actually adopted 100% until you found out. So,
Yes. Well, it sounds like it's going to be allowed, so there may be letters of protest in Australia or whatever, but until we get there.
Well, that's the shakedown done. So the F1 teams now move to Bahrain for 3 days of pre-season testing. It starts next Wednesday, so we'll report on that in 2 weeks' time. And then there'll be another 3 weeks, another 3 days starting a week later. So that's a total of 6 days. They generally only get 3 days testing for any given season, but because there's such a big change in the regulations, they felt that they needed 2 pre-season test events in Bahrain. So that should be
Which is the
great.
first time we'll see the Williams car hit the track as
Yes.
well, because they did not attend this shakedown unofficial test because, reading between the lines, the car wasn't ready. And so they're getting it hopefully all put together for Bahrain next week.
And they released the livery last night, so we can see what the Williams car actually looks like now. So we haven't seen it in actual flesh yet, just in photographs. And they got the London Bank has joined them as well now. They got a lot of sponsors, Williams. So maybe they're going to be a dark horse.
Is money the issue though in the cost cap era?
No.
Like I don't think that matters as much. It's not as big a deal if you don't have, like, you should be able to hit the cap relatively easily. Of course, there's now additional, I think, pushed through by Williams, additional tools that teams can use to spend extra money to like upgrade their facilities if there's a bit of a mismatch, because famously Aston Martin timed it perfectly with like being able to put a lot of investment into their campus, their Silverstone campus, with the investment coming from Stroll's consortium right before the cost cap came in.
Yeah.
And Vowles was always a bit salty that Williams couldn't do the same thing now that the cost cap was...
And they're an established team already.
Exactly.
And talking about Williams, Jenson Button used to be an ambassador for Williams, and he's sort of gone over to the other side and gone and joined Aston Martin as one of their ambassadors.
Well, he was actually a senior advisor to Williams. So it was actually operationally involved, and now I think this is now more an ambassadorial sort of role.
Yeah.
Of course, re-establishing his long-standing relationship with Honda, who are supplying Aston Martin for the foreseeable future. Of course, Jensen back in the day raced for British American Racing, which then became the Honda team, which then became Brawn, and the rest is history.
And Aussie Jack Doohan, he was going to go to some Super Formula or something in Japan. Where was he going to be racing?
Yeah, Japan Super Formula, which is the top flight motorsport over there.
And now
Super-seater.
Haas Toyota have added him to the F1 team as reserve driver. So that's pretty cool news for him. So
yeah, good to see him back in the paddock.
Let's hope one of the Haas drivers gets sick and Jack gets to go around in the car.
Ocon gets a bit of food poisoning.
That's right. Any more to add? Oh, so Lewis Hamilton. Now, this is only a rumour.
Yeah, we're now a gossip rag here at No Idea.
But coming off being producer of the F1 movie, he's sort of a bit of a social butterfly, one would say, and he's been seen with Kim Kardashian. Is that what's happening?
That's the rumor.
That's the rumor.
Yeah, if the Sun is to be believed.
So hopefully we'll see him on an episode of Keeping Up with the Kardashians soon rather than later.
Sorry, say that one more time.
I can't bring myself to say it.
Bahrain testing is next week, starts on the 11th. I think it kicks off in the evening our time.
Yes.
And then the first race is on the 6th of March, which is, of course, the Aussie GP in Melbourne. The only other big racing coming up soon is the Auckland Sail GP, which is on the 14th, not this weekend, but next.
And 9 o'clock tomorrow morning, Brisbane time, you can watch the NASCARs go around, but it's a pre-season non-point round, and there's lots of snow, and it probably won't happen, but fingers crossed, give me something to watch tomorrow morning. Any more? That's about it for the MotoRap.
Yeah.
My God, I could talk to you guys forever. But unfortunately, unlike No Idea, I've only got 1 hour here.
We said from who do we hear from? From tuning to 4ZZZ, and the show is No Idea with me, Max. We've got Ellie, we got Gabe, we got Peta. Hit us up, Gabe, with some of those texts.
Well, yeah, Dave, that was Dave from Eco Radio on the sting there. And we'll donate some of our 2 hours to you, Dave, with your texts. Does the alloy only create the electromagnetic field in salt water? About your
They
question
did not
with the hooks.
specify, but I would say yes, because a lot of things require the salt and salt water to in that specific measure. So yeah, I would say yes, but it was not specified.
There's not much long lining in fresh water either, so probably
not usually. No.
With the kilometres and kilometres of line. David texted in earlier saying, fun fact, ChatGPT cannot write your welcome to country speech. Got no idea about our Aboriginal languages.
Let's keep it that way,
About the creativity in the ChatGPT story earlier on. Bob texted in about your stuff with the hydrophobic tubes, Max, asking could you use it to raise wrecks from the ocean floor?
And the whole idea about the tubes is that they stay floating, so it's impossible to get them underneath a wreck and bring up a wreck.
A preventative tube floating device. Or it can stop a tube from sinking but can't raise it back up again. And Owen texted in about your undersea canyon story, Peter, saying the shocking part is that it lasted that long. Clearly it wasn't running Windows 11.
I genuinely had this thought when I was reading the paper. I read it like 4 times just to check. I was like, because they did say one of their cameras failed after a year. So something did go wrong. But I was looking at the footage. It is high quality. So no, I don't know where they stored it. I don't know how they kept the maintenance.
10 years.
They've also there's a little video that you can watch them picking them up at the end of the 10 years. And they've got a cool robot arm and stuff. Like they're teched out the wazoo. Honestly, they're fine. But I don't understand how it worked at all.
0420626733 is that text line. Sorry, Max.
And it does make sense because companies like Microsoft were testing out data centers, which they just drop into.
They put them underwater.
So it'd be a similar sort of setup. Just
famously, cameras aren't as happy underwater as they are on land. You do need to make some significant accommodations.
Yeah, and the one thing that they found, which was pretty funny, because they were underwater and in like a container. And no humans on board to accidentally pull out any of the blue wires in the servers. So they thought, from a maintenance point of view, it's actually
it just keeps people out.
But sharks do have a nibble every now and again. So,
Okay, we've got new member to the No Idea team. Ellie, what do you got for us?
All right, bear with me on this one because there are a couple of technical things. But before I want to propose to the group, how much matter in the universe do you think that we can see? Visible matter. Give me a percentage.
25%.
Oh, God. 0.0000003%.
Wow. I'll go with 10.
10. You're all in the right area. It's 5%.
We're
than 5%.
all in the right area?
I think that's very generous to one member of the team.
Pretty generous.
With a lot of zeros in their number.
Well, I mean, I feel like most people would think that it would be a lot more, right? So at the moment, we can only see 5% of the matter in the whole universe. It's crazy. But we also know that most of that matter is dark matter and dark energy. So that's 27% for dark matter, 68% for dark energy. So there is a lot that we don't really understand about most of our universe at the moment. Which brings me to a couple of mysteries that I want to try and get to the bottom of today with this new research that has come out.
We're not usually this ambitious, but this is great. I think this is a new turning point for us to actually do science on the show.
We'll see how we go with that. But basically, the first mystery that I'm going to propose to you is in 2023, researchers found that there was a neutrino slammed into Earth at 100,000 times the energy of our most powerful particle accelerators. So nothing we've ever seen before on Earth. It slammed into Earth at 100,000 times more energy. The mystery here is that this neutrino was detected by one experiment and not by another. So researchers are now kind of trying to find out why there was this difference. And it seemed impossible because this
like the energy dissipated between the two locations.
More so that one just didn't even pick it up at all, and one picked up something that we didn't think was even possible, this amount.
Right.
Yeah, so
right.
really, really strange. So this new research, which has come out recently from the University of Massachusetts Amherst, QS ranking.
Oh, we did this a few weeks ago.
530.
Oh, really? That high?
You have a pro-US bias that I'm trying to reduce.
120.
300.
247.
Yeah, C-Max. Not that low.
So physicists have suggested that this could actually be the exhaust from an exploding primordial black hole.
Whoa.
Yeah, huge stuff. So first I want to touch on what's the difference between a primordial black hole and a regular black hole. Anyone?
One that has soup.
Don't know.
Not far off.
Okay. Yeah.
No one's in the vibes of primordial soup.
Yeah, I got you. Yeah.
That was the joke.
Yeah.
So we all know about the regular standard black hole. They've got that life cycle. It was an old star. It usually runs out of fuel, implodes, a massive, powerful supernova, leaves behind an area of space-time which has such intense gravity that nothing, not even light, can escape. And we've seen photos of this. I believe the first one was in 2019. Pretty massive stuff. But there's this other type of black hole, and this was first proposed by Stephen Hawking in 1970. And it's a primordial black hole, which wasn't created by the collapse of a star, but in the universe's first ever conditions shortly after the Big Bang. So basically what this means is it could be a capsule of everything that was first existing in the universe. And this one is a little bit different because, they're usually they're a lot lighter than regular black holes as far as we've observed, but this is all theoretical at this point. So the other part of this theory with primordial black holes is that they are, predicted to emit particles, which is known as Hawking's radiation, if they get hot enough. So the smaller they get hotter and they leak faster. And it creates this runaway process where the black hole gets so hot and eventually explodes, releasing a catalogue of every particle in existence.
Oh,
pretty
cool.
huge. So this could, explain why we saw this really fast neutrino.
Alphabet soup.
Alphabet soup?
It's like the alphabet of the universe. Yeah. Primordial soup being shot up. Is that not what everyone was thinking? It's just like the building blocks.
It's a pretty cool way to see what first existed in the universe. So now we're getting back to this other mystery of why did we see it at one experiment and not another. So the experiment that did record it was KM3NET.
Catchy.
And the other one, which didn't, was Ice Cube.
Right.
Now, hang on. Yeah. Whoa. Props there, because astrophysicists don't usually have fun names.
Right?
Props to Ice Cube. What a great name.
Yeah, I
don't know why it's relevant, but it's sick.
I really respect that.
I'll cue the music.
Unfortunately, it didn't detect what we're looking at.
Yeah, but it looked cool doing it.
Exactly. So the question here is, if these black holes are exploding frequently, which we would imagine they are, why don't both detectors see the high energy neutrinos? And to explain this, what researchers have put together as a theory is that some sensors can catch this high energy neutrino while others don't because of dark charge. And what I mean by dark charge is it's a theorized charge. It's like a hidden copy of the electric force, potentially allowing dark matter to interact via a dark photon. And this is the model that could explain dark matter. It could explain, neutrino properties like we've seen, and it could be the thing that stabilizes a dark particle. And then dark electrons are the hypothesized particle which would carry this charge. And it's, dark electrons are the quantum state of solid materials that are undetectable by the conventional I can't do this word.
Spectronomy?
You know what? I'm going to let you guys say that because my mouth won't allow that. Yeah. But basically, that's why one could detect it and one couldn't, because there just weren't the right, tools and materials to detect this. And if you're wondering why we've gone from talking about neutrinos to now talking about electrons, it's because they're both part of the same family. In the standard model of physics, we've got different generations of particles, and electrons and neutrinos are the lepton family. So that's why they're buddies in that way. But basically, overall, while there are lots of nuances and technicalities to this, the main idea is that if this theory is correct, these exploding primordial black holes could be the next step in finally solving this mystery of dark matter and, the invisible missing stuff that makes up a lot of our universe. And not only that, but it could actually point towards this catalogue of matter that existed at the start of the universe, a really good snapshot of what happened exactly after the Big Bang.
Right. If we can detect it.
If we can detect it.
I gotta say, with ChatGPT and TikTok melting our brains at lightning pace, listening to Ellie talk about this, I can feel my neurons firing, synapses connecting. I feel like this is a way of rebuilding our brains, going into in-depth theoretical physics.
Listening to me talk about the most boring stuff you can imagine.
It's not boring. This is the thing. It's not boring. You just have to. It feels like grabbing onto the back of like if you're on a skateboard and you grab the back of a rubbish truck trying to madly follow where it's going. That's what my brain feels like. Because I'm like, okay, I've got that concept. Let's get another one. This is great learning. No, it's not confusing. It's wonderful. It's learning. We should be celebrating this.
Okay.
We love a new topic.
What is the independent variable that makes No Idea tick? That's what I want to know.
You tune into 4ZZZ, and the show is No Idea with me, Max. We've got Ellie. We've got Peter. What do you got for Sco?
Max, we're taking a hard pivot from dark matter into size does matter. Very different
is it definitely harder?
maturity of science. So I do want to put on a legitimate content warning at the start of this story that we are going to be talking about human sexual organs and human sexual reproduction. So if you're listening with small kids or if you're not comfortable with that, give this story a skip. Because there's no getting around what we need to talk about in this story, but it is fascinating for evolutionary reasons, specifically for the evolution of humans. So I want to take it. We'll get into the size does matter bit, but I want to start by just going back to what evolution is. Darwin's theory of evolution. By natural selection, our boy Darwin,
except he was actually a terrible person, but ignoring that.
Which was not just about natural selection; it was also about sexual selection of individual body parts. For instance, we know that the human penis, it originates from the need to transfer genetic material from the biological male to the biological female, same as in all species that have them, right? There's a natural selection need to just transfer the genetic information from the biological male to the biological female. So that's the natural selection.
To mix gametes.
That's the survival of the fittest, right? You have a survival benefit by combining DNA through sexual reproduction, and the penis is just the mechanism by which that happens in a lot of species. I'm keeping this as textbook as possible, but that's just the natural selection bit of it. That's the survival need, right? To continue genetic information. But if you look at something like a human and you compare it to our closest living relatives, you look at a chimpanzee and you look at a gorilla, the size of a chimpanzee's penis in the biological males and in the gorillas is far smaller relative to body size than it is in humans. Is this you shaming gorillas? It's not. This is across all of the living great apes. Bonobos, chimpanzees, orangutans, and gorillas, far smaller. Far, far smaller. You've never seen a chimpanzee's, have you? Or a gorilla?
I haven't looked, to be honest.
When you're at the zoo, you don't notice it, right? Because it's not there.
No.
It is pretty much imperceptible unless it's being used for sexual reproduction. But now I can't go to the zoo again
because I'm going to be looking. You've ruined the zoo.
Ruined the zoo. The question is then, if we know that like you need any great ape or similar animal, and humans included, require the penis for sexual reproduction purposes for natural selection, the question is, why is a human so large compared to our closest living relatives who showed that it's not, you don't need it to survive, it's not necessary. Yeah. So the one possible explanation here, and a strong explanation, is that Darwin's other theory of what fuels evolution, which is not natural selection, but sexual selection. Think of a peacock's tail. This is the classic example. When Darwin had published On the Origin of Species, detailing natural selection and evolution, he hated peacock's tails because they didn't fit. They didn't work in natural selection.
They're annoying.
They didn't fit the mold of incremental changes driven by survival of the fittest.
Peacocking it around, showing it off.
In one letter,
Darwin crazy.
He wrote, 166 years ago, he wrote, "The sight of a feather in a peacock's tail whenever I gaze at it makes me sick." because it didn't fit, right? It didn't fit into natural selection. There's no survival benefit to having a massive, colourful tail that you're dragging around, making you more conspicuous and slowing these peacocks down. 11 years later, he wrote The Descent of Man and the Selection in Relation to Sex. And in that book, he proposes this second mechanism that powers evolution, independent of natural selection and survival of the fittest. Sexual selection gives rise to features inherited generation to generation because they contribute to the success of obtaining mates. They don't deliver a set of genes a survival benefit. They just increase the successful reproduction those genes have.
Your likelihood of being able to mate.
Exactly. The peacock's tail, the lion's mane, the elephant seal's tusk, the sword tail of a swordtail fish, the bird of paradise's extraordinary plumage, the horns of a deer, the blue collections of a satin-bower bird, all of these things are powered by sexual selection. They're increasing the chance that those genes reproduce and pass themselves on, even though they don't confer any direct survival benefit. There's two things within that, though. There's within species competition, so like the elephant seals with their tusks, that is usually the biological males competing with each other, right? So that's part of it. That's not a survival benefit. That's them competing with each other to have better reproductive success. And there's mate choice, which is usually driven by the biological female of selecting which male to reproduce with successfully, right? So there's two parts of it there. Neither of those things are giving you a survival benefit. One is usually males competing with males, and the other is usually females selecting the male mate to reproduce with. As a side note, there was a big pushback when this first came out and for many decades after, and still is to some extent, for a lot of reasons, but partially because it for the first time pushed some of the power of evolution into females, biological females, right? Because it concedes that it's not the biological males trying to become a perfect specimen that all the females will then. It's not like they're competing for one goal within the species, and when you hit that goal or get close to it, you have the most reproductive success. It acknowledges that there is an innate sense of choice and preference within usually biological females doing the mate choice. Obviously, there's examples where it's different around the animal kingdom, but usually it's biological females having that mate choice, which then acknowledges that the biological females can have a preference. If it's a bird that is pretty drab looking, except for maybe a white patch on its neck in the males, and that's one of the things that the females look for in choosing a mate. If one of the females gets born with a genetic mutation or a behavioral difference that it learns to go for yellow objects, then all of a sudden, if a male gets born with a yellow object, that female's preference in reproducing, as long as she's successful in doing that in her own right and successful at surviving in her own right, will change the evolution of that population. So there was a big pushback there. Then we get, of course, into how this comes into what we were talking about, which is the human penis and the evolution of the human penis through sexual selection. So there's two parts we could look at here. The first being female mate choice. Is there, in women who are attracted to men, is there a driver there of choosing mates with larger penises? In 2013, an Australian study came out specifically looking into this.
Of course we did this.
They got 100 students and staff and non-university personnel.
Hopefully separately.
Across Monash University and ANU. They were private during the experimental phase. Yes. And they're all female heterosexuals is how they're identified in the paper. And they presented them with life-size projections of anatomically correct 3D computer-generated male figures that varied in their height, their shoulder-to-hip body ratio, and their penis size. And they found that the women in these studies preferred taller men with broader shoulders and a larger penis size. That's what they had, which is the first bit of it, right? It would make you think that the reason humans are well hung compared to our great ape and relatives is because of sexual selection from the sides of biological females who are attracted to men. But that's not the whole story, because it's mate choice and within species competition that can drive sexual selection. Right. So what this new study has done is the same research group. And this time,
good for them. They're just really interested.
They included heterosexual men in the study. It comes out of UWA, University of Western Australia, and the Australian National University, ANU. Can I get QS rankings for those two?
Oh, no, don't do this. I think ANU is like 20.
Yeah, that'd be like 30, I reckon, ANU.
Yeah.
ANU's pretty
They're
high up there.
32. What
UWA,
about
I've got no
UWA?
clue. Maybe 74.
Yeah, 80.
77. Very
Damn. Yeah, see, I don't know why you guys have a US bias when Australia is hitting so hard.
So it was a very similar sort of test. 800 participants in this one. They showed them the figures. They varied in their height, their body shape, and their penis size, and they showed them to them on life-size projections and also in different circumstances, like on phones and things. They found the same result. They found for women a larger penis, a greater height, and V-shaped upper body all increased a man's attractiveness. For men, it was the same. Men considered a larger penis as an indicator of a rival with both greater fighting ability and being a stronger sexual competitor. And they also rated taller other male figures with more V-shaped torsos in the same fashion. So there is a male competition aspect to not just the penis size, but also the height and V-shaped torso.
It's very difficult to test nowadays, though, because humans have evolved so much intelligence that we have societies now where there's external factors that you wouldn't find in necessarily a fish.
For sure.
You know?
There was one very interesting difference between the women and the men, though, was that in the women they tested, there was a diminishing effect beyond a certain point. Further increases in those features didn't increase their perceived attractiveness anymore. Whereas in the men, the taller they got, the larger they got, the more they overestimated the attractiveness of these characteristics. So, and they did also note that for the men they were testing, the effect of penis size on attractiveness was much higher as the effect of fighting ability. So the sort of, as a fighting competition was a smaller effect. It was mainly perceiving them as being more attractive. Males perceiving other biological males as being more attractive the larger they were.
Right.
The more gifted they were, we'll say.
That's why we wear clothes, Gabe. Yeah.
And that's why we wear clothes. So what that means is, just like the mane of a lion, the human penis serves three functions: sexual reproduction, attractiveness to women, and
primarily
scare off other males.
Yeah. Gabe has a lot of penis facts in his brain, just generally.
That's going to be another little...
Another sting for the show.
Sting for the show, there we go.
All right. Now, the good thing is we may not have Max, we may not have Gabe, but we do have penis facts.
Triple Z.
We want to appeal to your senses.
No idea. Space news. Artemis 2. They did the wet dress rehearsal. I know you don't like that saying, Peter, but that's what they call it.
It sounds awful.
It's when they fill it up with all the propellants to see if anything leaks. And of course, as we know, like Artemis 1, the hydrogen was spewing out of it. So they still have to fix some of the... Got to get the big spanners out, really, and fix up some of the valves so the hydrogen doesn't leak. They also did some testing on the Orion space capsule. They pressurized it, and it was also an unsuccessful test. It took too long to pressurize, so there must be a leak somewhere as well. Right. So that doesn't augur well for passengers on board the Orion spacecraft. H3, this is Japan's latest rocket. Apparently it lost its payload back in December. It was carrying the Mikibiki 5 navigation satellite, and it held on for a little over a minute. The jolt from stage separation dislodged the satellite from its mooring atop of the rocket. The second stage lit its engine and left the satellite behind. And they know this because they had a rear-facing camera on the second stage capturing a fleeting moment of the navigation satellite falling back to Earth. Japanese space officials reported that the Mikibiki 5 fell into the Pacific Ocean in the same impact zone as the H3's first stage. There's more. Apart from losing its payload, the second stage's engine can only manage 80% thrust. So some think it was actually fortunate that it did lose its payload. The engine managed to fire long enough to put itself into a low Earth orbit. But alas, the orbit was also too low, and the H3 second stage re-entered the atmosphere and burned up within several hours. 2032. We know it's going to be the year when Bluey opens the Brisbane Olympics, but it may also be the year when the moon gets another crater. It has been calculated that there's a 4% chance that the moon may be struck by an asteroid named 2024 YR4. It's a 60-metre wide object and is slated to hit the lunar dirt on the 22nd of December 2032. If the asteroid hits, it will release enough energy equivalent to a medium-sized thermonuclear weapon. The resultant crater will be roughly 1 kilometre wide and 200 metres deep and produce a 100-metre pool of molten rock at its centre. Comparing it in size to other craters on the moon will help scientists understand the bombardment history of the moon. And here's the real kicker. Up to 400 kilograms of moon rock is expected to survive re-entry to Earth, creating essentially a free large-scale lunar sample return.
Oh, very nice.
Yeah.
How kind of it
Silver lining.
to be free and returned. Yeah.
That's
I would say it's high-speed returning,
Yeah,
unlike
sure.
what we usually do. It's just a little more violent.
And Artemis 2, I've looked at NASA's website, Max. They're targeting March as their earliest launch
Yes,
opportunity
that's
now.
right, yeah.
There were some February dates floating around up until quite recently. Those tests did not go very well.
Science out, Gabe.
That is all we have time for. Thanks for tuning in.
We don't want to talk about the SMSs?
Oh, yeah, we should.
Sorry.
We got some great text in about that.
Fantastic text today, everyone.
We had John texting in, but baboons are, well, let's say decently hung. So I'll look into it, John, for you.
Gabe will
try and
specially
figure out
look it
what's
up.
going on with baboons off the back of that last story. Celeste is asking, why is a human penis not retractable?
Agreed.
I think a lot of people have the same question. And Marky texting in saying, I think I hate my life more now because everything about this topic that I've told myself is not true is now, from what I'm hearing, scientifically correct. But thank you. I've finally been informed and can actually believe my own crap.
Yeah, sorry about that.
Well, I don't think entirely correct, but an element of truth to it for sure. They do in the study say there's lots of caveats on the results about human culture and who they were testing and all that sort of stuff too. But yeah, that is all we have time for. This Dark Matter filled show is brought to you thanks to all the subscribers to 4ZZZ. You can join them at 4ZZZ.org.au. There's a new monthly sub prize if you do subscribe during February. What is it, Peter?
There is. You can get yourself 3 mixed cases of White Lies beer from the White Lies Brewery. And if you visit them in person, they're also giving a $50 Yeasty Boys pizza voucher for their wood-fired pizza, which sounds really lovely. So if you want the chance to win that sub prize, make sure you subscribe. There are multiple different ways you can do so. You can do that at our website,
4ZZZ.org.au, which is also where you can listen back to the full recording of this show with all the music as well as a bunch of our previous shows. The condensed version's available on your podcasting platform of choice. Just search up No Idea 4ZZZ. That's No with a K, 4ZZZ. And you can watch us back on socials at No Idea 4ZZZ as well. Thanks to Toby for editing up the pod. Thanks to you, Max, Ellie, and Peter for your stories this week. We'll be back in your ears next week. Between now and then, don't use an ice cube to detect dark matter. Don't worry about getting bitten by a zombie worm. And don't wait up for the Artemis 2 launch just yet.
And we'll speak to you next week.
Yeah.
Bye.
I'm a goddamn marvel of modern science.